GameSci.com. GameSci.com. Welcome to GameSci.com. I am Professor Chris Ferguson. GameSci is where we learn game programming and computer science at the same time. This is CS1, Intro to Computer Programming. This course is a series of 10 lessons, and this is lesson number 3, Selection and Control Statements. Since we will be building a simple game piece by piece, it's best if you watch the videos in sequence. While we build a simple game, you will also learn object-oriented programming and the important concepts of computer science. I am Professor Chris Ferguson. Enjoy the course. Okay, let's start with the if statement, which is known as a selection or control statement, so called because they select which code to execute or they control the path the program takes. The if statement is known as a one-way decision. You're going to either execute a block of code or skip that block of code. This is where the logic of computer programming comes. Computer programs would be very boring if they always executed the same code every time. And what selection and control statements do is allow the code to execute different code under different conditions. Alright, so here you can see a very simple if statement. Alright, we'll get started. It starts with the if portion and what's called a condition or a boolean or a true-false value. Anything in the parentheses after the if statement is evaluated to be true or false. We'll start with a score of 2. You'll notice over here on the right side, the variable score. This is the variable score. It has the value of 2 in it. So when evaluating this expression, the value of score 2 is decided whether it's less than the value 3. All right? Well, 2 less than 3, we all know from the 3rd grade, that is a true statement. If this condition, or if this Boolean value here is true, what the if statement says is execute the block of code inside the if statement. The open curly brace here at the end of the line says we're going to execute all the code between this curly brace and that curly brace right there. So as I advance the code, right, you'll see it goes inside the if statement. Because the condition or Boolean was true, we're going to go inside the if statement and execute the system.out print line. It is true. And you can see down here in the output that it is true showed up. Right? Now, when it's done executing the code in the if block, what will happen? It will simply execute the if statement. It will continue on the path that the program was taking. Right? So that is a very simple if statement. If the statement is true, execute the code inside the block. Now, let's redo this statement again, but now let's set the value equal to 4, the value in the variable score equal to 4. Now, if we change the value of score to 4, you'll see that the expression, the Boolean statement, evaluates differently. We'll take the value 4 out of the variable score. We'll evaluate 4 less than 3, and you can see that is a false statement. Everyone from the 3rd grade should understand the relationship between 4 and 3 less than is a false statement. As a false statement, this time the code will not, I repeat, will not execute the code inside the if block. It will simply skip past it and exit the if statement. So you can see the code took 2 different paths based on the Boolean or the condition in the if statement. Right? Let's try one more time. Let's set the value of the variable score to 0 this time and see what happens to our if statement. Again, we've updated the variable score. It now contains 0. This time the code executes. Retrieving the contents of the variable score being 0, doing a less than 3 operation on that gives us a true result. 0 less than 3 is true. As a true statement, what is this code going to do? The code is going to enter the if block and execute the code inside the if block. Once again, you can see it is true shows up on our output. Right? When the condition is true, execute the code in the if block. And of course, when that code is done, it simply exits the if statement and continues on with the program. So, there you have it, a very, very simple if statement. If the condition is true, we will execute the code in the block, the system.out.println. If the condition is false, we will skip the code in the if block and continue on with the program. Nothing complicated about an if statement. Let's move on to the if-else statement. The if-else statement is sort of an upgrade or an improvement on the if statement. Whereas the if statement is a one-way decision, the if-else statement is a two-way decision. It gives you two options. One block of code to execute when the statement is true, a separate block of code to execute when the statement is false. If-else is still a selection or control statement, so named because it selects which code to execute. And you'll see that very clearly. This if-else statement will select one statement to execute over the other. It's also called a control statement. Control statements control the path the program takes. And you'll see that this statement has two separate distinct paths that the program can take based on the condition or Boolean value following the if statement. Let's get started and trace this code. We'll start with our if parentheses damage greater than 5 end of parentheses. What is inside the parentheses is what we call a Boolean or condition. It should evaluate to true or false, but never both, only one. So, with the value of a variable damage set to 9, right, and an initial value of 10 in the health variable, 9 greater than 5 is a true statement. As a true statement, we understand that we're going to go inside the if block and execute the code immediately following the if statement. And into the if statement we go. Again, the condition or Boolean was true, so we'll execute health equals health minus 3, right? And you can see the value of health went down from 10 to 7. Right? Now, what happens after we execute the code in the if block? What happens after we execute the code in the if block is we simply skip the else. The else is the alternative, so if we determine the condition was true and we executed the if block, we will skip the else and continue on with the program. See how this program is controlling the path of the program or selecting the code to execute? It selected the if block to execute and it skipped the else block, because the condition or Boolean was true. Now, moving on, let's set or start again with damage set to 2. This time, we'll change the value in the variable damage. We'll leave what was left in the variable health to 7. We'll see what happens with a different value in the damage variable. Okay, so retrieving the contents of the variable damage, which is 2, and evaluating 2 greater than 5. The relationship between 2 greater than 5 is a false relationship. It is not a true statement. As a false statement, this code will select a different path to execute. As a false statement, it will, as we know, skip the if portion. But this time it will go to and execute the else portion of the code. Because this condition was false, it skips the if and goes to the else. So now we want to execute the code in the else, which increases the health variable by 1, right? And see what happens. We execute the health equals health plus 1. You'll notice that the health variable went up from 7 to an 8, right? And it all happened because our condition was false. Alright, after it's done executing the else portion of the code, it will continue on with the rest of the program. See why it's called a control statement? What that happens here is it controls the path the program takes. It controls which code executes. Alright, let's try this again. Let's start with damage equals to 13 this time. Let's change the value in the variable damage. Right? So the next time this code executes, damage has a different value. The condition or boolean may come out to be something different. So we'll set damage greater than 5 as a true statement. A large value in damage makes this condition or boolean true. As a true statement, can you tell me what's going to happen to the code? Why, yes, it's going to enter and execute the code in the if block. Right? As a true statement, we enter the if block, right? And we subtract 3 from the health variable. Notice how health went from 8 to 5. The health is going down when this statement is true. Now, of course, when it's done executing the code in the if block, what happens? We skip the else. Remember, this is a two-way decision. We're going to execute one set of code and skip the other. So we skip past the else and continue on with the program. One more time, just to make it clear, let's now reset damage to 5. Remember, health, we're going to leave the same. And we'll see how this code reacts differently with a different value of damage equal to 5. With damage greater than 5, well, that's a false statement. 5 is not strictly greater than 5. So this is going to come out to be false. As a false statement, what do we think is going to happen? As a false statement, we think that we are going to skip the if block and go to the else. When we skip the if block and go to the else, we'll execute the code in the else block. We'll do our health equals health plus 1. Our 5 just went up to 6 because health became 1 more. After executing the code in the if block, we will exit the if else and continue on with the program. So you can see clearly, an if-else two-way decision is choosing one of two different paths to execute the code. Depth at what's called a relational operator, or the thing that actually produces a true-false result. There are many of them: less than or equal to, not equal to, greater than or equal to, greater than. All relational operators, as you should have learned in 3rd grade, return true-false results. And it's these true-false results that drive the if-else, and the other selection and control statements. So let's run through an example that goes through all the different relational operators and see how they work. Right? You'll also notice on this if-else statement that I did not use curly braces on this example. I prefer the curly braces, but they are not a requirement when there's one and only one executable statement. You can see in the if portion there is one statement that prints true. You can see in the else portion there is one statement that produces false. If there's one and only one statement, I feel I need to show it to you like this because some people program this way. Again, I prefer putting curly braces in no matter what, but in this situation, since there's one and only one statement, we don't have to use curly braces. So let's show it to you that way. Now let's go ahead and get this baby started. Let's start with the less than operator. Right? You can see it looks like a left arrow there. The current value of the age variable is a 19. So if we look at 19 less than 18, that is a false statement. As a false statement, we know what's going to happen. It's going to skip the if portion and go to the else. So it goes immediately to the else and executes the system.out print line and prints the word false to show that the condition evaluated to false when this code executed. And of course, the program would continue on afterwards with something else. Now let's try the less than or equal to relational operator. We'll plug in a new value for the age variable here and see what happens with the less than or equal to. This time the age variable contains the value 18. And so when we evaluate our relational operator, it'll be 18 less than or equal to 18. That is a true statement. Because of this extra equal, 18 less than or equal to 18 is a true statement. As a true statement, what's going to happen? we should know by now it's going to go inside the if portion and execute the system.out println true. Right? So not only does the different relational operator affect true or false, the different value in the age variable will affect whether it's true or false and determine which statement it executes. So with the statement of true, it'll print the true to the output, right? And we'll continue on. Let's try it again with a different relational operator, this time the greater than. We'll also change the value of the age variable. This time it's going to be 16. Right? With a current value of 16 in the age variable, when this code executes, 16 greater than 18 is a false statement. It is not true that 16 is greater than 18. The thing I'm trying to get through to you with these repetitive examples is it always boils down to true or false. Is this true or is this false? In this case, it is false, so it'll skip the if portion. When it skips the if portion, it goes to and executes the else code, and it outputs the word false. Right? 16 greater than 18 is a false statement, and it executes the code in the else. Let's try the greater than or equal to operator. Let's try a different operator, different value in the age variable 20. 20 this time is 20 greater than or equal to 18. That is absolutely a true statement. As a true statement, what's going to happen? It's going to go inside the if code and execute the statement in the if portion of the if-else statement. System.out println is true. You can see the new true shows up on our output. Remember, these are multiple executions of the same code using different relational operators, different values of the age variable. We expect different results. It will choose to execute a different path depending on the true-false value of the relational operator. And of course, when it's done with the if code, it simply skips the else, as we well know now. So those ones, less than or equal to, greater than or equal to, those ones you should have learned in the 3rd grade. Here's some ones that you might not have learned in the 3rd grade. Next up is the equal to operator. Now be careful here. That's two equal signs next to each other. Not a single equal sign, but two equal signs together. A single equal sign would be the assignment operator. Two equal signs is the equal to relational operator that says, tell me if both sides are the same. Now in this particular situation, we have 17 in the value of the age variable. So what we're really asking here is the 17 in age equal to the 18, the literal on the right side. And the answer to that is false. They are not equal. They are not the same value. Never have been, never will be. So it evaluates to false. When the Boolean or the condition statement evaluates to false, it of course skips the if, goes to the else block, prints out the false statement in the else block because the condition was false. And you can see the false shows up on the output. One more. Let's look at the not equal to operator. The not equal is simply the opposite of the equal to operator. Provide a new value for age. This time it's 21. And we'll ask, is 21 not equal to 18? And that is a very true statement. 21 never has been and never will be the same as 18. Trust me, I've been past both. So, as a not equal operand, a relational operator, it is going to be a true statement and it's going to execute the code in the if block. Once again, the true shows up on the output, right? And after it executes the system.out println, it will skip past the else. So there you have it. Those are the 6 different relational operators. And again, depending on the value of the variable age, they will return a true or false. When it returns true, the if portion of the statement executes. When the Boolean or condition is false, the else portion executes. Pretty simple, pretty straightforward. Like I say, most of this you'll learn in the 3rd grade. Now you just have to learn how to program it. Now let's look at a related topic to selection and control statement, something called a flowchart. Now, what is a flowchart? It's a graphical representation of the execution of a computer program, or a graphical representation of the logic of a computer program. We'll start with the very simplest flowchart, the if statement. Remember, the if is a one-way decision. We are either going to execute a block of statements or skip a block of statements. Here is our generic if statement. If some true-false statement in the parentheses, if it's true, let's execute this block of statements. If this evaluates to false, let's skip past this block of statements. So with a true statement, we will execute this block. With a false statement, we will skip past that block and continue on with the rest of the program. And this is what the flowchart is trying to show us. Now, as I start the animation, you see we do the if true false condition first. All right. Now, in this situation, while we're evaluating, let's assume a true condition. This statement, whatever it is going to evaluate to true. Well, what happens if it evaluates to true? You can see over here, we execute the statement inside the if block. You can see on my flowchart, it's showing, take this path that says true and follow this arrow down to the block of statements and execute it. So, what the flowchart is showing you graphically is what's going to happen when this evaluates to true. It's going to come down to this block of statements. And of course, after that block of statements executes, we will exit the if statement and continue on with the program, and that's what this little arrow here is showing you. After the block of statements, continue on with the rest of the code. So that's the past if the if condition is true. Let's now show the false path and see what happens. Once again, we come to the if portion, and in this time, we're going to be looking at a false boolean or condition. What happens when this condition inside the parentheses evaluates to false? As I advance the animation, you'll see in the if statement, it skips past the block of statements, past the closing curly brace, and nothing executes. And if you look at the path outside of the flowchart, it takes a path that takes it around the block of statements and continues on with the program. That's it. All the flowchart is doing is graphically showing you what this code is doing. Now, why do we do flowcharts? Well, mainly because not everybody reads and understands code. If you want someone outside of the computer programming world to understand what your code is doing, we often illustrate what the code is doing in a flowchart. And by diagramming the code with a flowchart, the less technical, less program abilities people can understand what the code is doing. The military is very big into flowcharts, right? The general doesn't understand the software that's running the missile. He wants to see a flowchart of how that missile is going to behave. Very important. So that is the flowchart for the if statement. Let's move on to the if else because it does have a different flowchart. So let's flowchart the if else control or selection statement. The if else is a two-way decision. It has two separate paths that it may take during the execution. And you can see over here on our flowchart, we have two separate paths. One path for true and a different path for false. So moving along in the animation, we go to the if control or boolean statement. And we'll assume right now that we're dealing with a true condition. So whatever is in this parentheses after the if evaluates as a true statement. Well, we all know what happens when it's true. We go inside the if block and execute the code in the if block. And you can see that if this evaluation evaluates true, we'll go this way. Now, a word on this flowchart. True, false, or Boolean statements always happen inside of diamonds. Why? Because diamonds have these nice little pointy edges that we can label are true and false to indicate the path the program takes. Right now, off of this point of the diamond, we're going to say, well, the condition was true, so we'll take this path and execute this block of statements. Just like this code is indicating that it took the if portion because it was true and is executing that block of statements. Now, what happens after that block of statement executes? Well, we should all know our control statement, our if-else statement, is going to skip the else. If it executed the if portion, it always skips the else. And you can see here on the flow chart, it skipped the else and is continuing on with the program. Now, what happens if the condition or Boolean is false? So, we're going to execute this code again. And this time, let's assume we're going to have a false result to our condition or Boolean. Well, if the condition is false, we should be familiar with this by now. It's going to skip the if portion and go down and execute the else. This is a two-way decision. It's going to take the second path because the condition is false. The flowchart, again, true-false statements are in diamonds because diamonds have these nice points, and we'll label the point false. This is a path we want the program to take, and this is a block of statements we want to execute because it is false. And of course, after it executes the statements in the else block, it will exit the if-else statement and continue on with the program, and that's what we're showing over here. After this block of statements, we will exit the if-else statement. That's the flowchart for the if-else statement. 3 points I want to make about flowcharts. Number one, true-false statements always go in diamonds, so we can label the output true or false. Regular statements go into rectangles, like we see here. And lines coming from blocks or diamonds always are labeled to show the direction. After all, it is called a flowchart. And what this is showing you is the flow of the program or the path that the program will take. So you have to label. Also notice that flowcharts, a good design flowchart, should have a single entry point and a single exit point. So that's the flowchart. It's for diagramming the logic of a computer programming, or diagramming the path, especially for non-technical, non-programmers that need to understand what the code is without being able to read the more technical code. So let's move on to an extension of the if-else statement. And this isn't really a new statement. This is just a different way to do an if-else statement. And what we're going to do is we're going to sort of chain or domino multiple if statements together by immediately following the else with another if. Remember, the if-else was a two-way decision. You could take one of two different paths. Well, what if you need a three-way decision or a four-way decision or a five-way decision? If you need to decide between one of 5 different paths, you're going to have to use something a little more complicated than an if-else statement. And that's what we call the else-if. The best way to explain an else-if is to use the animation and show the path that the program is going to take. Now, in this particular situation, we're going to select between one of 4 different paths. Now, what do I mean? It can execute this code, 1, or execute this code, the second alternative, or execute this code, the third path, or execute this code, the fourth path. So this is what I would call a 4-way decision. When the code starts, it's going to pick one of these 4 different options and ignore the other 3. So let's see how this works by starting the animation. Well, we start with our if statement. You can see I filled in some values for our variables over here. Let's put 12 in damage. Let's put 100 in the health variable. We'll change this every time, so it'll take a different path every time. We'll keep health as a cumulative variable. It'll change as the program goes. And we'll see how that happens. So, damage contains a 12. So, 12 greater than 10 is what? 12 greater than 10 is a true statement. as a true statement, what's it going to do? It's going to dive inside of that if statement and execute the code in the if block. Right? 12 greater than 10 was true, so we execute the code in the if block. Now we all know what happens when we do that. Health goes down by 8, so my 100 changed to a 92. Right? And then after we execute that line of code, we will move on. Now, here's where you got to be careful. If you look closely at this else block, if you look real closely at this else block, there is a single if-else statement after that else statement. So we know that we have to skip the else. If we skip everything in this else statement, guess where we're skipping to? We're skipping past all the rest of the code. So when this initial statement here is true, it's going to go in, execute the code in the if block, and skip the entire else. We're choosing one path of the 4 different options. I know it might not seem like all of that's in the else, but I put a box around it so you can clearly see to show you that all of this is part of that else statement right there. So we skip past the entire thing because the if condition was true. Let's try this again, and this time let's set the damage variable to 5 and see how a different value in the damage variable will take us on a different path. So damage is now 5, health is 92, 5 greater than 10 is a false statement. As a false statement, what's going to happen? What's going to happen when the condition is false is it's going to go to this else statement. This else statement right here is tied to that if. So if this if is false, it's coming to this else and going to do this if. Now, damage is still 5. 5 greater than 6 is a false statement. See what I meant by the domino effect? How it's going to fall from one to the next? 5 greater than is 6 is a false statement. Where are we going? Well, if the if is false, this if right here is false, we're going to its else. So I'm advancing from this if to that else right there and going to execute the next if-else statement. Sort of a waterfall. We're going to step down to the next if. This time, our value in damage of 5 is greater than 3. We do have a true statement for this if statement. As a true statement, what happens? As a true statement, we go this if statement true. We're going to go down and do our health equals health minus 2. And you can see our health value changed from 92 to 90. Health went down by 2. Now, if the if was true and we executed the code in the if block, what happens next? We skip this else. Now remember, it was this if was true, so we executed that code here, and as always, when the if is true, we skip the else and we leave the block. What we're doing is we're choosing between one of 4 paths, and we just happen to take the third path in this case when damage was equal to 5. But wait, there's more. Let's start damage equal to 2. Health is still 90. Damage is now 2. Different value in the variable damage might alter the path that this program takes. 2 greater than 10 is a false statement. As a false statement, we will go to the else and execute the if that is part of the else. 2 greater than 6 is also a false statement, so we will exit the if portion and go to the else. This else is attached to that if. This if is attached to that else, so we'll execute the else code and evaluate the third if statement. Well, evaluating the third if statement, 2 greater than 3 is still a false statement. So all 3 of the if statements evaluated to false. So where's it go? It goes to that final else. So this if was false, so it jumped to that else and executes the code inside the else. So if all 3 of the ifs are false above it, that's when this final else executes. And when this final else executes, it subtracts 1 from the health variable, We're down to 89 in our health variable. Of course, when the code in the else completes, it will leave this else and exit the code and do it. With this if-else statement, we've gone from a one-way decision with the if, a two-way decision with an if-else, to what we call a multi-way decision. Pick one of these four different paths. Kind of like a video game, right? When you approach a room, there's multiple options you can take. You're going to select one of these four different paths for the code to execute based on these relational operators, these true-false conditions. You can do a 5-way decision, an 8-way decision, a 10-way decision. It gets a little complicated and ugly once you get past 4 or 5 different paths. So where's another option? And we'll look at that next. This is called a switch or case statement, or switch case statement. It is also a control or selection statement because it's going to choose one of many different paths to execute. It is a straight-up competitor to the else-if statement. When you have to choose between 4 or 5 or 10 or 20 different options, you can choose to use an if-else statement or an else-if statement, or you can choose to use a switch case. Now, I'll be honest with you, if you have 10 or 20 of these, switch case is a lot simpler, a lot cleaner to do. Depends on the number of different paths your program may take. The bigger or the more number of options your code can take, the more likely it is you'll want to use a switch instead of an else if. Again, the best way to show it to you is to just animate it and see what happens. We're going to switch on the variable weapon. Depending on the variable weapon, we'll select one of these different cases. Now, we'll start with weapon equal to 1. So when we switch on weapon, we're switching on 1. Now what will happen here is it will compare the value 1 to one of these multiple different cases. Right? It'll compare it against this case, or this case, or this case, or this case. Right? It's going to compare it against the different cases. Since weapon was equal to 1, case 1 will match it. Weapon matches case 1. That is a true statement. Since weapon matches case 1, as you might suspect, it's going to execute the code in case 1. Since weapon was 1 and weapon matches case 1, we will execute this code and set weapon name equal to shotgun. Right there. After we execute weapon name equals shotgun, what's going to happen? It's going to go down to the next line of code in the case, which is the break statement. And what the break statement literally says is break out of the switch. Break completely out. Do not pass go. Do not collect 200. We're done. So what this break statement says is to execute the code or exit the code completely. Break out of the switch and continue on with the program. What we're doing, we're matching the value in weapon to several different cases, and depending on which one matches, we'll execute different code. Do you see how this is a replacement for the else if? But it is considered a much cleaner, nicer way to do it if you have a whole lot of options to choose between. So let's set weapon equal to 3 this time. Now, with weapon equal to 3, look what happens to case 1 this time. Case 1 doesn't match. The value of weapon is 3, so matching 3 to 1, there is no match. This is a false statement, so we will not execute the code in case 1. Now again, weapon is 3. It does not match case 2. This is a false statement. Weapon does not match case 2, so we will skip case 2. We'll go on to case 3. Now we have a match. The value in weapon is 3. It matches case 3 of the switch. So weapon 3, case 3, it's a match. That is a true statement. Guess what goes to happen? We'll execute the code. Weapon name equals Uzi. You'll see the value stored in my weapon name variable updated to Uzi. Weapon 3 matched case 3. We're executing the code in case 3. After we execute the code in case 3, we encounter the break statement. The break statement says what? Break out of the loop completely. We're done. Do not pass go. Do not collect $200. Exit the case. What you can see here is we're selecting one of these cases to execute. Now, let's start with a weapon equal 99. Turns out we don't have a weapon 99 in our system. So when we start matching weapon 99 to the different cases, something strange is going to happen. 99 does not match case 1. So what happens? It falls through to case 2. 99 does not match case 2. So what does it happen? It falls through to what? It falls through to case 3. 99 still does not match case 3. So what happens? It tries case 4. It's just going to go down the list, testing weapon to see if it matches any of these cases. And in this case, 99, once again, 99 does not match case 4. So this is a false statement. We are going to fall through to the next case. Which gets us to the last case, which is called the default. The default basically matches anything and everything. The default is there so that if none of these cases match, which happened in this case, we will execute the code in the default. Since there was no match to any case, we will execute weapon name equals fist. We'll see that weapon name modified, updated to fist. And we then execute the default. And you can see the default, when it's done, will exit the switch because there's nothing left to execute. We could have put a break statement here, but it seemed kind of redundant since this was the last case. It was going to fall through and exit anyway. So what about that break statement? That break statement is important if you do not want it to fall through to the following case. In this case, if we got rid of that break here, when it matched case 2, not only would it set weapon name to pistol, but if that break was missing, it would fall through and execute case 3 at the same time. So that break is pretty critical if you do not want it to execute any more cases. There you have it. There's the switch case statement. Yet another control statement. Moving on. Now let's look at the AND logical operator. Logical operators allow us to kind of string more relational operators to get more complex conditions or booleans. The AND is represented by 2 ampersands in a row, just like equal equal is the equal to relational operator. Ampersand ampersand is the AND logical operator. AND means exactly what the English word AND means. Both sides must be true. If to get into Stanford you need good grades and high SAT, it means both of those things must be true for you to be accepted into Stanford. Or as I like to say it, all true to be true. That's how the AND logical operator works. All true to be true. Here's what we have a truth table. We got condition 1, which is a true-false value. We got condition 2, which is a true-false value. All possible combinations of these two true-false values. What is the result when you AND the two together? So again, if both sides are true, the result is true. If there's even a hint of false in this, then the truth table indicates that the AND is false. All true to be true. Now let's see how this works when it comes to computer programming. Here we have an if statement where I'm connecting two relational operators, here and here, together with an AND logical operator. I assign some values to these variables. My rating is set to M, my age is set to 18. And I look, is if rating equal M, well, that is a true statement. That does match. Age greater than or equal to 17, 18 greater than or equal to 17 is also a true statement. So both sides are true. Now when both sides of the AND are true, what does the truth table tell us? All true to be true. When both sides are true, the result of the AND will be a true statement. So overall, when I AND both of these together, I get a true statement, and whatever's in the if block will execute. All true to be true. Let's start this over again. Let's give different values to ratings, different value to age, and see what happens. We've got a new value for the variable rating, so that's a T. T equal to M is a false statement. So the left side of this and is going to be false. The right side, 17 greater than or equal to 17, is still a true statement. So one side is false, one side is true. Looking at the truth table, what is my result? Looks like it's going to be false. And if you and a false and true together, the overall result would be a false. This if statement overall, this if statement is going to evaluate out to false. And whatever code is, if there is an else, that will execute, not what's in the if portion of the code. So you can see the AND logical operator simply allows you to tie multiple relational operators together, right? And it more significantly requires all true to be true. If everything is true, then the result of the AND would be true. No matter how many conditions I tied together with ANDs. They'd all have to be true for the overriding condition or boolean to be true. That is the AND logical operator, and as you might suspect, there are other logical operators out there. Let's now look at the OR logical operators. That's two vertical lines up there. OR logical operator. The OR is the shift, and above the enter key, you'll see that vertical line. Two of those together is the OR logical operator. Now, the OR logical operator means exactly like the English language OR means. If you have to clean your room or take out the trash for your mom to buy you a new video game, it means you only have to do one, not both. Again, here's what we call a truth table. All right, condition 1 is the first true-false value, or the left-hand side. Condition 2 is the second one, or the right-hand side of the OR logical operator. And if you OR those two together, what is the result? Well, the way I like to think of OR is all false to be false. What does that mean? All false to be false. The only time an OR is false is when all your inputs are false. If your mom says you have to clean your room or take out the trash, and you do neither, she's not buying you that video game. Only one has to be true for the result to be true. Of course, if both are true, you're good, but only one is required for the OR to be true. This is the OR logical operator. Animate this and see how it works. We're going to set up some variables, a Boolean variable that has a true-false value, and credits a integer variable that has a value. Now, paid user is set to true, so the left-hand side of the OR is already true. Then we'll look at the right-hand side of the OR. 37 greater than 100 is a false statement. As a false statement, doesn't really matter with the OR. If one input is true and the other one is false, the result is still true. Remember, OR only means one of them to be true. Since one of them is true, overall, the OR itself is true. Only one side has to be true. The only time an OR is false is if it's all the inputs are false. So let's look a little more in here. Let's start again with different values for paid user and credit. Now paid user is false. So the left side of the OR is going to be set to false. 91 greater than 100 is also a false statement. So now we see a situation where both sides of the OR are false. So both inputs to the OR logical operator are false. What's the result when that happens? As you might have guessed, it's false. So the OR itself comes out as a false statement. So the overall condition of this if, right here, this whole thing evaluates to false because all false to be false. If all my inputs to an OR logical operator are false, it's going to have a false result. So that's the OR logical operator. Let's look at one more. And that's the exclusive OR logical operator. It's sort of like an up arrow key right there. I believe on my keyboard it's above the 6, right? It's kind of an up caret. Right? This is called the exclusive OR. Again, think of what the English language means. Exclusive OR. It means I only want one OR, right? Exclusive means exclude. I only want one of them to be true. And that's what this means. Only one can be true, not both. So looking at the truth table, right? on either side of the exclusive OR. Go through all combinations of condition 1. Again, that's a true-false value. Go through all combinations of condition 2. That is a true-false value. So exclusive OR means if both inputs are true, the result will be false. Exclusive means I only want one true for this to be true. So what's going to happen here is kind of different than any other time. 2 true inputs is not good. We're going to get a false result with 2 true inputs. Now, what does exclusive OR mean? It means I only want one true. So if I have one input true and the other false, I'm happy as a clam, the result is true. And vice versa. If the first input is false and the second one is true, exclusive OR, only one is true, the result is true. What does exclusive OR mean, or the XOR operator as it's sometimes called? Different is true, same is false. If the 2 inputs are the same, the output will false. If the 2 inputs are different, the output will be true. If they're the same, the output is false. Let's again run through an example here with the animation. Rank greater than 10. Rank has the value of 14. 14 greater than 10 is a true statement every time. So one input is true. Then we'll go look at the other input. Weapon value, WEP-val 27. 27 is greater than 20. That is a true statement. Strangely enough, that's bad if you're looking for true. 2 inputs of true, according to the truth table, should produce a false result. And if I continue on here, I see that the exclusive OR does return a false. If the inputs are different, the result of the exclusive OR will be true. If the inputs are same, be it 2 trues or 2 falses, the output of the exclusive OR will be a false. Let's run it again with slightly different values and get a different result by design. Now, rank greater than 10. I changed rank to 6 for the input here. Rank is 6. 6 greater than 10 is a false input. WEP-val of 21. 21 greater than 20 is a true input. So, with a false and true as input, what is the truth table telling me? The result should be true. And when I click on it, it certainly is. When you exclusive OR a false and a true, it produces a true result. Because if they're different, it will output a true. There you have it. The logical operators, AND, OR, and exclusive OR. There's also a not logical operator, but it's really simple. Not false is true. Not true is false. Anyway, the logical operators are used to create more complicated conditions or Boolean values to be used in if-else statements and else-if statements. Good luck. Talk to you later. See you soon.